explored a little bit TypeFlow, choose TypeFlow as their topics. So, well, so this is, I'm gonna start with very basic things. If you have already, learned TypeFlow before or tried TypeFlow before, the first part of this probably gonna be a little bit dry. So, but like we need to, guarantee everybody, we need to guarantee like everybody can get out to the board. All right, so let's get started. So we've already talked about the TypeFlow a little bit like in last week. So just in case you haven't downloaded the TypeFlow, so very simple, just need to go to Google, search TypeFlow, it will pop up, and the first page you just need to accept their agreement and download the first one, and from the compressed package, just find the right version for your Macs. And remember to download the example things as well, because that's a really good source to learn TypeFlow. All right, so to install your TypeFlow, just as other MCG or just as others plugins, you just need to find out your plugins folder. So if you are like install the Macs as it is, you didn't customize your path, it should be in your programs folder as Autodesk, 3ds Max, and on the certain version. But like if you installed in your custom ways, you custom path, and maybe you showed up like memory, like storage on your C drive, something, you just need to click on your right click on the icons and just like open the file location. It will directly open the Macs folder for you, and your plugins folders should be there. So this is my 2019 and my plugins folder is over there. You just need to drag your TypeFlows once, like 2019 TypeFlows over here. All right, so just in case you're gonna use TypeFlows or plugins in the future at school computer, and you probably don't have permission to access the C drive, so you can't drag anything into the C drive. So there's other way you can do is just put all your plugins into a specific folder, probably on your USB drive, and you can go to the customize. There's a configure users and system path, and on the third-party plugins, you can add that path to here. And after that, restart your 3ds Max, it will automatically load into 3ds Max. All right. So, and the other thing I want to mention is because last class, I think some of you have difficulties locate the hotkeys. So it's a little bit difference between 2019 and 2021 or 2020. So I think after 2020, you could find this hotkey editor under the customize. But if you're using 2019, you need to go to the customized user interface. So you can find all the hotkeys over here. So the hotkey Max mentioned in last week is, I think, is show end result. So just type in show end result over there, and we can find out the out plus this dot is the hotkey, and you can remove that and override whatever you want over here. So that's just some tips on the hotkey. All right, do you guys need like 1 or 2 minutes to, just make sure all of you installed TypeFlow? Are you there?
Yes, please.
Yeah. So
do we also need the example files right now or no?
You don't need to open the example files, just download it. You can export that during this week. So I just mentioned, that is just like a really good source to explore TypeFlows, because if you open the example files, you will notice the Tyson has write really clear instructions and descriptions in those example files. So that's a really way to learn typeflow. Yeah.
They're quite big, so maybe don't download them right now.
Yeah. Just no need to download the examples now.
And
So
just,
you,
Could
yeah.
you send us the link, please?
Yes,
Thanks.
I can do that. There we go. Chat.
can you just for us to make sure we've installed it properly, just show us what we're meant to see once we have installed it?
Okay, cool. Yes. Let me paste the, yeah, thanks, Marcus. Just noticed that. So actually, I'll open the folder you download. I think it's this one. So if you download a typeflow, if you extract the file, you will have this folder. I think the latest one is followed by 16090. And if you open that, there's a couple of them. I think you have typeflow 2020 as well, because I've already dragged that into my plugins folder. It's not over there. Just like make sure this number is matching your max number. And after that, you can restart the max. So after, if the typeflow is successfully downloaded and installed on your computer, under the creation panel, you should have this typeflow button under the object types. And there's probably one reason if you haven't, if you install the typeflow successfully, but there's no buttons over here, that's probably because you don't have the VRay installed. So I think we can get the VRay free license from Sweden. Is that right, Marcus? So if you have trouble access, download the VRay and get the free license, probably just contact the Sweden ITT and they will instruct you how to properly download the one just for Sweden students. So for VRay, I think for 2020 you already have VRay 5. So just download the VRay and the installation is very straightforward. Just keep the default and press the next. It will automatically install on your computer and it will work fine for us really next. All right, so if you have successfully downloaded typeflow and installed VRay, you will have the VRay panels, which is over here, and you will have the typeflow icons. All right, is there any question about this?
I have the typeflow button, but I don't have that panel up top.
Oh, that's fine. So as long as you can download the VRay later.
Okay, yep.
I think we don't really gonna talk about the rendering today. So we're just simply using typeflows, but you want to using typeflows with the rendering, function, you probably need the rendering. All right, cool. So
it'd be good to have that up and installed and running by next week though, because we will probably go through a bit of material stuff next week.
Yeah.
And in all seriousness, if you have any difficulty, just contact Swinburne IT. They're sitting there waiting for your call.
But is there any other plugin, any other rendering program other than VRay that would be good with Macs? Because I really didn't like the VRay when I used it. It's just very complicated.
There's what, 20, 30, maybe more render engines that you can use with Macs. In terms of a simple render engine, Octane was pretty simple, but also kind of a little inflexible. It comes with something called Arnold, which is, I think product designers love it. it's not very common in industry for architecture, and I don't know, I found it a bit difficult to use, but people do swear by it. It's I think it now Arnold has GPU rendering as well as CPU, so it might be okay, but I didn't like it myself. But then if you've been using a couple of render engines for a while, maybe there's a bit of that prejudice of liking the old system. V-Ray, incredibly flexible, and yet it is probably a little bit tricky, but that'll come with anything that's got the flexibility. So, but we'll go through some basics, and there are a lot of online tutorials that we can share with you as well. I think I like it because it kind of, you can use standard materials, which are the kind of old material types. There's a bunch of stuff that you can do with standard materials that's really useful for kind of architecture and urban design. But it also uses physical materials and it's V-Ray materials, and it's what the kind of architecture industry has been using in various forms for, I don't know, a couple of decades, probably nearly. So there's a lot of support, good community, and it integrates pretty well with other stuff like is it Unity or the other one?
Unreal Engine.
Yeah, Unreal has its own version. You can, and also it's something that you'll find in a lot of offices. So,
Yeah.
the V-Ray will be sitting there with Rhino, or if you're in ArchiCAD, I think there's a V-Ray for ArchiCAD. So there's a lot of benefits.
Thanks.
Yeah. So you just don't drag all of your like TypeFlow, if you download that folder, don't drag all of them into your Max plugin folder. Just drag exactly, if you have like Max 2019, just drag them. And if you drag that, it will immediately create some particles from that. So particle system is really old, and it hasn't changed since last decade. So it's powerful, but really hard to use. And thanks to TypeFlow, so we have this new tool, and you can basically program as it's actually the visual programming. So if you have, I think most of you probably have a little bit experience with visual programming before, like the Scratch by MIT is kind of like visual programming, Grasshopper, or Dynamo for the Revit. All of those are visual programming. So same as the TypeFlow. So you can actually program your particles in the system. So that's just some like background story. So let's start with TypeFlow now. So to start with TypeFlow is actually very simple. So you just click on the TypeFlow icons over there and drag into your scene. There will have an icon over there. It doesn't really matter how big is this icon. It's just like, an icon shows you where is your like TypeFlow, where is your TypeFlow landed. And this is not really related to your particles, so you can put it anywhere in your scene. All right. So after you drag it, like we need to go to the modify panel. So it will show us like what's the options we have for the TypeFlows. Oh, so just actually, if any of you had experience with particle system before, there's one difference between the TypeFlow and the particle system is the particle system, if all the particles you create is within one editor. But for the TypeFlow, each of the icons, like each of the TypeFlow icons contains one, has its separate editors. Say, this is my new TypeFlow, icon, and that's pretty empty. But I have other TypeFlow icons already in my scene as well. So if I click on that, I open the editor, that's open a separate windows for me. So they are completely separate, and those particles won't, communicate with each other because they are separate things, if that makes sense. All right, so let's keep talking about the type. So if we click on that, go to the modifier panel, the first thing you will notice is the editor. So this is the main place you're gonna work within the TypeFlow environment. So here you have your viewport. It is called viewport. It should be pretty empty over here. And you can see there's cache enabled. You can right click on that. You can disable your caching. So what does this mean is actually particles, TypeFlows can do some simulation to speed it up. It will save those simulations to your memory, to your caches. So if you have your cache enabled, the computer doesn't need to do the simulation every time. It just needs to do it once and save, like it will remember in your memory. And if you play it next time, it's much, much smoother. And also you will find these are the operators we can use for the TypeFlow. Did you get this? So there's actually three very important concept in TypeFlow. One is flow, and the others is operators, events, and connections. So actually, what is flow? So there's some preset flow already in the within the TypeFlow. If you right click in your viewport at the preset, let's have just really simple icon flow to have a look. So this is the ticket flow, and this is under each of the windows. This is called the event, and under each of the events, we got different operators. So that is basically what TypeFlow is. And if you create that what this simple preset flow can do is actually it creates several particles and make it follow the icon direction and drop it. So let's take a close look at this. So if you have a close look at these operators, actually you could find them in different colors. So basically the concept is all the things in green, which means it's gonna create some particles. So let's change the display to pixels. Those are the particles you created.
That's a quick question, sorry. How are you applying the effect to the logo?
You don't really need to apply it to logo. It directly linked to the logo. So what you need to do is you click on this logo.
Yeah.
Go to recreate from creation panel. Go to the modify panel next to it.
Yeah.
And there's open editor. Open it. And what I did is I right click on the empty viewport and go to the presets flows and just add a simple icon flow, add to the scenario. So that this simple icon flow is a preset flow, already made by Tyson, which we can start it very quickly. Okay, cool. So so the green one actually basically the different ways to create different particles. So the very basic one is the bus. So if we have a look at the bus, it will have the start frame. You can set that the end frame. So this start and end frame is corresponding to your animation screen, animation frames. So, and you can set up how many particles you want in the whole simulation. So if I now set up the end frame to 0, which means like it's gonna generate 200 particles at the frame 0. So if I set the start frame as 0 and the end frame to 200, which means it will generally generate 200 particles during these 200 frames. All right, you also have the options like you can create per frame, like how many particles you want to create per frame, or you can add the repeaters. So now we have particles generate. We have like 200 particles generate from 0 to 200. All right, so what's the next thing it did? It added a position icon. The position icon, if you don't have the position icon, just have the first, like the particle system just have no idea where should we like put the particles. So that's why we need to have the position icons. So position icons, you can find it under the blue area, which will under the blue icons, which is here. If you drag the position icons onto the viewport, you will see actually there is empty. It asks you to pick icons in the viewport. So that's where we need to drag an icon. So to find the icons and the other TypeFlow modifiers, we need to go back to the creation panel. Let's go to the helpers. And under the drop-down menus, you will find TypeFlow. And there's a Ty icon. And you can also find Ty windows and other Ty slicer Ty actors we can use within the TypeFlow system. So let's just have a Ty icon and just drag it onto the viewport. So actually now, because I mentioned these TypeFlow icons has actually the location and the size of that has no relationship with the simulation we do within the flow, but the icon we created, it actually has like definitely have relationship with the particles we created. So the size defined, you know, how big we can create icon onto that, and the direction may be gonna like define which direction the particles can go. So you can set the logo size doesn't really matter, but like you can definitely set length and width over there, and the location define where the particle gonna happen. Let me have a look at the chat. So where do you? Yeah, thank you, Pat. So yeah, let's get back to my simple TypeFlow. So that's the position icon in the viewport, and simply just use the pick that icon from your viewport. It will like after that the particle system will know where it should generate the icon. And now if we have a look, all the particles gonna generate on this icon, but it is just generated on there. It's just burst onto there, but like no simulation at all. To have like some simulation, we need to add a speed onto that. So speed also you can find in the blue icon operators. And let's have a close at the speed. Actually, under the speed, we can set lots of things. So in the magnitude actually is where we can set the velocity. So how fast it should go. So if you like change this number higher, it will go higher. And if you change that lower, it will go slower. So if you change to the particle's going to drop this faster than if we set it to 1. Also, we can set different directions. So it's probably hard to see. Let's change my to large dot. So yes, That will be much more clear. So now we set this along the icon, which means we can set these particles sending out directions followed by a tide flow icon. So if you set it to the along icon arrow, and you can pick a tide flow icons over there. If this is gonna define where the particles can go. So now if I rotate this icon to up, all my particles gonna go up because it's follow these icons. Also, we have the other options here. So there's many directions we can choose to do lots of things. We can just follow the particle X. It will only go, follow the X, and we can go random 3D. It's gonna go anywhere, random, random 3D direction. Also, here we can, for auto particles, we can set up some stress noise onto that. If we set up some noise onto that, it will not directly go straight. It will have some noise apply onto the particles. So now you will notice I always have this display on. So actually the display, if you don't have a display, the particles will be invisible because they are just single, they're just particles. So if you want to make them visible, you need to have this display apply onto that. There are some default, there are some types you can pick. You can have large or small dots. They are not real geometries. They are just the way you display the particles. So, and we can have the geometry. So if we have geometry onto that, we'll find out there's nothing happening over there yet. You just have a bunch of particles still within this in the viewport, which is because there's no shape applied to this geometry. So the particle system doesn't know what kind of shape we're going to use. So that's where we can have the shapes. So you can also find the shape in the beige area here. So just apply the shapes, and under the shape, you have lots of options. You can have 2D. You have 2D options there. Also, you have lots of 3D options under here. It's covered most common shapes. If this is not enough for you, for example, I want some teapot actually flowing above, just shooting above, I can use a reference node. Under here, I can pick the teapot, and these will automatically replace all the particles, and I can have my teapot go rips, just going up. And the next one is the mesh. If you don't have the mesh, that's completely fine if you're just doing a simulation. But if you want to export the particles to the real scenarios, or if you want to have them rendered with the rendering engine, so you need to have a mesh and set up to either triangle mesh or render instance. All right, so this is a very, very simple tide flow. It's basically composite with some these kind of elements. So you usually will have a bus to bus the particles. Then you tell the particle where the particles should go, and then you have some force, add the force or speed onto that. You probably want to give some shape onto the particles, and then you display this. So this is the most simple particle flow in the particle system. Any question on this?
Yeah, so I have a question. My particles won't attach to that logo thing. So nothing's coming up when I'm trying to put that birth into, how yours were floating. I have nothing there.
Did you just use the preset flow, or you just do directly from the scratch?
Just like that, how you've done the icon.
But like there's nothing happening in your viewport.
No.
Even you drag the timeline, there's nothing happen.
Yeah, same here. I've got the same problem. Can't find that plane. It's just the icon.
It works for me here.
If you're using actually a preset flow, actually you don't need to manually draw an icon onto your viewport. It will automatically draw a viewport, draw the icons into your viewport. And maybe your icon is, probably check your units, see is that like you are really far from the 0, point. Because for the preset, it will automatically draw the icons onto the 0, point. Or like you can try to click on the zoom extent selected and just click on that. It will zoom to the content in your viewport.
What was the shortcut for zoom extend?
It's just like at the corner of your 3ds Max, right bottom corner.
Tianyi, how did you get the? I have all the particles flowing down from the sort of the 0, coordinate. How did you get it to flow? How did you get your arrow to stick up?
So to make it stick up, you just need to rotate your type flow icon. Just select the type flow icons over there. Just rotate it. You can rotate to any direction.
Sure. I clicked the reverse thing. That's why I couldn't work out why it was. Yep.
Right.
Thank you.
No worries.
I have a question.
Yeah, go ahead.
You know how you drew the icon on the actual canvas? What was the purpose of that? Like not the one that you have in the middle. You drew one and you said that if it's bigger, it's going to make a difference and whatnot.
Okay. So this is just a preset. Sorry. This is just a preset type flow. So if you don't use a type, if normally you won't use a preset type flow, so you will start from scratch. You have a type flow icons over there, and if you open that, that's empty. If you want to, start from scratch, just directly drag the bus over there. And now you need to draw your own icon, because the icons won't automatically draw into the viewport. You need to like manually draw that into the viewport.
Got you. Thanks.
Nice. So do you want to have like 1 or 2 minutes play with it? Or
yes, please.
Yeah, cool.
I think another way to explain it is basically that type flow is basically like a grasshopper script that you have, and then you open it up and then you have all the components within it. So each type flow icon is basically one script.
Yes, that's correct. Yes, I think that's very, good description for type flow.
When would you ever actually use this though?
It can do lots of things. Like it can, have you watched I think Avengers 3? Do you remember the famous, snap finger effect? That can be done with type flow. So all those kind of simulations can be done type flow, but that is more like a movie effect or animation effect end. But we can actually use these functions on maybe data visualizing in 3D on some really complicated 3D modeling systems. How to say that? It's same reason we use Grasshopper, I guess. So
yeah, so you can use it to create complex geometry, or it could be about you could use it for optimizing geometry. If you, it depends on which area you're in, but for urban design, there's a lot of potential, particularly if you can kind of bring in simulations of pedestrian movement mixed with light simulation, sort of stuff that, complex systems that we work with in, designing cities, but also in architecture. You can use this in, it could be, because you can program in quite a bit of intelligence into these, in this case, particles, but they could be voxels, they could be, room arrangements that are kind of sorting themselves out. So there's lots of exciting potential in architecture with this stuff, and it can look groovy and blobby and cool, or it can be used for more conservative looking stuff that's just really sophisticated in its arrangement.
All right. So I guess let's continue. So that's actually what we know. It's very basic from the type flow. So already learn a little bit from the preset. So now we can actually do something from the scratch. We're gonna create our own first and create our own flow. So the first one I want to show you guys is this kind of like the firework thing. So I have these particles burst from my icons, and it's kind of like explode to like sprawl to more particle dots and then disappear. It's trying to mimic these fireworks. So if you're interested, I can show you from the start. All right. So it's actually.
Tianyi, sorry to interrupt.
Yep.
There's a question from Jimmy. I don't quite understand the question. Are you able to verbalize that, Jimmy?
Yeah. So I tried to create a second type flow, and then once I clicked on the object type, I created another type flow. How do I get to the step where I created that flat box 2D flat box with the arrow?
Oh, this tie icon. So I can walk you through it. Walk you through the whole steps when we created like fireworks. So
okay, great.
Yeah. Cool. So let's hide that fireworks. So the first thing actually we need to do, of course, we need to create a tie flow icons over there. And the next thing we need to do is we need to create a tie icon. So under the tie icon actually is under creation panel. Help us, this little triangle thing, and under the drop down menu, you will find tie flow, and just drag that tie icon onto your viewport. So does this answer your question, Jimmy?
Yes, thank you.
Okay, so now we have those two, just the only thing we need for the firework. So now we click on this tie flow icon, go to the modify panel, open the editor that's added this flow. All right. So what we want, the first is we want to burst some particles from the icon, right? So let's have a burst. We just simply click on the operator and drag that into the viewport. Okay, so we probably don't need to have 200 that much, because we want to sprout into, like, we probably just have a few and then sprout into like more particles in the following steps. So let's just keep that probably 0 to 30. So we want, and then have like 10 particles shooting above onto the scenario, onto the viewport. So start and set a end frames, and I set the total as 10. So now there's nothing will happen because we haven't assigned that to the tie icon. So now what we need to have is we need to have a position icon over there and drag that onto the bus. So if you drag that, there's a little green line just under the bus, just drop it over there. And then you will have the tie icon, like position icon. And then we need to pick the icon for the particles. Just do pick and pick that icon. So after that, if you drag the timeline, you will see the particles actually, generate on this icon. Okay. From now on, the particle still doesn't do anything because it doesn't have a speed, and it will only generate on this icon. So next thing, we need to drag a speed under the tie icon. So speed over here, drag that, find the green line, so with here. So the default setting for that is the particle is gonna go random 3D, but we don't really want that. We want it follow the icon direction. Actually, reverse the direction. So we can set the directions to follow the icon arrow. Let's pick the icon again to let the particle know which icon it is. So after that, you will find your particles actually, shooting down. And actually what is shooting up. So really simple, just click on the reverse. It will reverse that. All right. If you find out like these small dots really hard to see, you can change the display to maybe larger dots. All right. We're good for now. So there's other thing to mention is also you can change the dot color as well. So you just simply click on the color over there, and then you can pick whatever color you like. So I'm gonna pick a bluish color to there. Okay. So now we have some particles shooting about. But if you have a close look as the firework we created before, it's kind of like it's not really following the completely the arrow icon direction. It's goes a little bit random to the side and start to dropping down. So let's do the dropping down first. So for the dropping down, we need to add some gravity onto the icon. So by doing that, we need to add a force. So just add a force onto the speed. And on the force, if you don't pick any force, you will find there's a built-in gravities over here. We don't really need to set it to really. This number is really, you probably need some testing. So what is the best number for this? If you have this as 1, your particles probably too heavy. Let me close my firework. Your particles probably too heavy to drop. If you have them too small, they probably, like too light to make it like really like to mimic the gravity. So, and that is really related to the speed as well. So it depends on what is the velocity you set to the speed here. So as we mentioned, we can set the different speed along here. So if this number is higher, which means like your particle is going to go faster, and if you get this smaller, your particle is going to go, slower. And I'm gonna set this to 1 to have a look, see if it is all right. So
Just a quick question. What's your
yeah.
unit set to? Because mine's set to meters.
I think for now the files working on doesn't really set the set unit is system unit is meter too. So that's actually for the particle system, particle like type flow particle system. I think it doesn't really matter your units. It's gonna ignore your units, but like I work in meters, probably meter is a safer way to work.
Because like my magnitude numbers and stuff are different. Because like it shows like 0.025 meters. So,
Right.
Yeah.
So your default is not. So if you set that.
That sounds like you're in feet and inches.
No, it says M, so it says 0.025 M, and when I go unit setup, it's set to metric meters.
In your system units, because there's two different spots to set units.
Okay.
So when you go to customize unit setup, there's the kind of display units, and then deeper in you go into the system units.
Yeah. Okay, so now if you have the false unit set up, false setup, you will notice if you apply above 1, it will like actually speed up the process is shooting up. So for the gravity, we probably need to have a negative number. Apparently, my number is too high, so probably -1, and still barely can see it's blowing up. So I changed the speed to higher, maybe 5 meters. So then I can have a clear look, like it's shooting up and starting to falling down. The first time when the simulation running, probably a bit weird because it's just trying to do the simulation and saving the simulation to your cache. Once after that, you will have a smooth outcome at the time, at the simulation. All right. That is
Any idea why mine just keep going up off the screen? They don't come back even though I put gravity in.
Did you set the gravity to, negative number? So yeah, so if you set to, above 0, that will like speed up the particles shooting up. So if you set it like, lower than 0, it will like become more gravity.
I put it as negative and now it starts at 0 and just goes down.
That probably because you don't have enough speed. So in that case, we need to change the speed to a higher number to make it more obvious, like to make the effect more obvious. So my suggestion is I set up my speed as 5 and I set up my gravity as -0.1.
Okay, don't worry about it.
Yeah.
It just goes straight, it goes down and disappears all the way down now. It's faster.
Yeah, mine's doing the same.
Yeah.
Same here as well.
Yeah, same.
Did you set to your
It's not going up first, then down, it's going straight down. No.
Along the icon, did you set as reverse?
Yes.
Yep.
Ah.
It works for me. Mine goes up first and goes down.
Okay, let's have like 1 or 2 minutes to do the troubleshooting. So I'll show you what I have for my settings, so you probably can follow again. So I have my bus start from 0, end frame at 30, and the total number is 10. So there are 10 particles shooting up. And my position icons, I just create a position icon and pick that position, like type icon. And then I add a speed, and my speed was set to velocity, and the magnitude is set by value, and my magnitude is 5. And the direction is along icon arrow, and I set to reverse, and I pick the icon in the viewport. So it will not follow the icon arrow, it will actually reverse the icon arrow, so it will shooting up. So
I don't think I've got the pick. Okay.
yeah. So actually, there's a way to track like which step you did wrong. So if you see all of these operators, actually you can click on this little icon. Once it goes gray, which means it has been disabled, so you can check what if without this operator, if your like particles goes right. So if I disable my force, my particles just directly go up into the timeline end. All right, so then after that, I have my force, and I have my building gravity set to negative 0.1. And after that, my particles just like go up and start to dropping down.
Yeah, it's working now.
Cool. All right.
I think I have the same
Drop
problem
down.
as
Sorry.
Cameron.
Mine, I hadn't selected the icon the second time. That was my issue.
Right. So so for all of the speed, like along the icon arrow, actually it will not know like which icon you are following. Actually, you can have 2 icons. So for example, you have one icon to generate your birth, your generator particles, but like you don't really want your particles follow this icon's direction. You probably want your particles follow this way. You can create another icon in the scenario and pick that icon for your speed direction. So that will follow that icon. So those 2 are completely separate. So that's why you need to pick the icon here. So then we have the gravity. So if you notice the fly work I did before have a little bit of variety on the direction when it's shooting up. So it's like, it's pretty normal, like it's pretty common to add some noise or add some varieties onto all of the simulation. So almost all the operators give you that option. So for here, so along, we can set this divergence. So if we bring this divergence higher, let's set up to 10, you will see my particles won't directly go straight anymore. So it has a little bit of variety. And I can bring this number even higher. So it will have like, you know, more obvious effect. Okay. So under the speed, the magnitude is the one define the velocity, the speed, and the divergence is the one set up the variety. All right. And if you remember the firework I did before, once it's coming up, and to a certain point, it started to explode to more particles, and the older particles disappear, and the new particles just follow the direction dropping down and disappear to, you know, try to simulate the same thing a firework did. So we can do that by add more particles with the prow. So with the sprout, let's add a sprout underneath the force, which gonna create more particles we have. So to see those particles, let's have a display. So if you notice, like some of the operators, when you added it will have a little bit node allow you to connect others. So for example, this proud, which means these particles can be sent out to another event. So let's have a display for this proud and make it a different color. So you can choose the color from here. So let's have maybe a yellow. And under the spout, you can set set on entry. You can set offspring. So this is how many particles generate from one particles above. So we have like 10 particles there. So I probably want to have like 10 particles per those 10 particles. So we totally have like 100 particles there. So after you set it up, I don't have. So the other thing about TypeFlow is, like we talked about the layers in the previous class. If you hide the TypeFlow icon, so if you hide those TypeFlow icon, the TypeFlow simulation is gonna be hide in your viewport as well. So that's a really simple way to manage your TypeFlow. So now that's my, those are the yellows. So if you notice these yellows, we actually generate 10 per those particles, but there's only one. Seems like there's only one generated from those particles, which is because all of those 10 particles are stick together. There's no speed on that. So will looks like one over there. Actually, there's 10, overlay on each other. So what we're gonna do is actually, yeah.
Could you just do that again? The spawn.
Okay. So no, that is the one. The spawn is very simple. You just like it's onto the bus over here. Spawn, drag that under the gravity, and set this offspring. So you don't really need to set up to 10. I set up to 10. You can set up to 5 and make it a display as a different color.
Mine's working, but the spawn dots are coming out of like a different part, like a bit further over. Is that all right?
Yeah, that's all right, because we haven't set any force onto those board yet. So maybe actually to set some, to make it much more clear, let's do send out in front of this spawn and make it spawn to the second event. So we can, like, all the things we've done in the second event only happen to this spawn. So now we need to add the gravity again onto the spawns, because we can see, although I added 10 particles per those 10 particles, I should have like 100 particles in my scenarios, but now I only have this many. So let's copy these four. So all of the operators, you can right click on that and do a copy. And just like put it where you want to add, just right click and paste. So there's two paste types. So if you just paste, you just paste the operator and there's no relationship. Like if you paste the instance, you will notice all the font become like italic, and which means these two are linked. If you change one, it will change another. If you change, like they will like interact with each other all the time. Same as the instance types we have in Max's clone system.
Tianyi.
Yeah.
It might not matter at all, but does it matter the order in which these things are listed?
They do, like, so the order of these operators define which happens first.
Okay. Thank you.
No worries. So,
Could
good.
you show you how the gravity was linked again? So I'm just trying to figure out how to get that back in there
So
as well.
for the gravity link, so
Yeah.
let's delete that falls over there. So I just right click on operate over there, copy, and at the place I want to paste, I just right click and paste instance.
Okay.
So then they will link to each other.
And
Is
how,
it
how did you choose the color that it changes to?
So the color, you can actually just click on the color.
Okay.
That way, and then you can change the display color.
Easy.
so my event number 1 now no longer works? Is that
Yeah.
normal?
Yeah, that's normal
Okay.
because we haven't finished the setup yet.
The other thing that you can do if you're having trouble like with just the dots is you can display them as ticks or other things. Ticks, sprites. I don't know what they are.
Sprites.
Dots, pickles, pixels rather.
Yeah, they're pretty much the same size. All right, let's continue. So, and after that, not only we want a gravity onto the new particles, we do want some variety or like direction randomly onto the particle. So we need to add a speed. So as we did in the sample one, add a speed, just keep it as random 3D.
We could have just copy pasted, right? Just want to make.
Yeah. The other way to, add an operator instead of drag it, actually you can like just move your mouse. Move times to continue. Yeah. Move your mouse at the place you want to add the operator and just use your tab. So here it says press tab for quick type. So tab, and you can type what operator you want. If you want to have a speed, you can just like tap speed and enter. It will add a speed over there. All right. So now you will see actually this did like we do have like 100 particles there, but it like our first group of particles is disappear and it stopped going up, which is because all of those as happens too fast. So we want to do what we want to do is want to do a time test. So we want to do when these kind of like when the all particles happens maybe over 60 frames, then the second sprout happens. So that's time test to do. So time test is in the yellow section. So let's drag that over here. And because the time test already had a send out, so we don't need to send out anymore. So let's delete that send out and connect that time test. So I'm gonna set this value to 50 to have a look. So now I have my red one going up, and after 50, after the red one like happened 50 frames, the yellow one happens. The second group of sprout happens.
Why have I lost the first group altogether? I can only see the second group now.
Did you add the time test?
Yeah.
And maybe set the event age greater than 50 or 60 if you have the same number setting as me.
Yeah. I've got the same value there, but I didn't have the, even before this step, I didn't have the first lot. They've disappeared.
Is it send out? Did you delete send out?
No.
So
the time test comes off that one.
Yeah. So the reason we had a send out before is we don't have any, send out operators in the first event. Now we have a time test. It has a send out operator abundant with the time test, so we don't need to send out anymore. And we just delete it and
that fixed it.
Cool. So if now you follow the step, you should have like one color particles shooting out and spouts into more particles and just dropping down.
Can you show your settings for the spawn? Mine's just like going one for one. It's not like bursting into the.
Okay, so the spawns, the one you control your spawn number is at here. So under the spawn 100%, and there's offspring. So offsprings. So offsprings define how many particles gonna spawn per one particles you had before. And of course, you can have some varieties over there. So which means it will have a variety over those offspring. They won't have exactly 10 particles per old particles.
Also, Tianyi, could you please show how to change the elevation of the fireworks miner on like the 0 ground plane?
The elevation of the, so you mean change the elevation of the firework? Does that mean like your fireworks just don't go up?
They're going, no, they're sort of exploding on the ground actually.
Okay, so the reason happens to that probably two reasons. So either you don't have enough speed in your first group, so you can change your magnitude to a higher number. So my set is to 5, so you can set up to 10. So the higher number means like you have like bigger force to push the fireworks going up. And the other one is the gravity. So you probably have like too much gravity set to the force. So mine set to minus 0.1. So if you change this to a smaller number, you will have less gravity to drag that onto the ground.
Okay, I'll give that a try. Thanks.
Yeah, no worries. All right, all good. So actually, we already like achieved the kind of like a firework effect. So if we want to do a furthermore, we'll probably these second group fireworks can burst into further things as it keep the dropping down. So by doing that, actually that's the same as the second group. So you just need to add a sprout underneath of that again. And this time we probably don't do random, we'll probably just like do that by its travel distance, see how it's look. So let's have another displays. And set to another color and have a look. So the second sprout, the third group of the particles will generate along the traveling direction, traveling speed, and keep dropping down. So that's it. And that's probably happened too fast. If you feel like, okay, that happens too fast, and my second group sprouts almost can't see, we can add a slow. the smell like icon one underneath of that, and maybe change this to 20. Drag this, and then let's have a look. So now probably 10 to more. Let's have 10 perhaps. Yeah. All right. So basically that's actually what we want already. So you probably notice the firework won't actually in the real life won't be there all the time. They will, disappear eventually. So then what we want to use is delayed. So let's just drag the delayed underneath of that, underneath of the second group as well. And on this delayed, we actually want it happened based on the event age. So at each of the particles maybe happen 10 to 20 frames, then it's disappear. So by doing that, we can change the timing from on event entry to event age. And I'll set this to from 10, 20, probably this from 10 to 20 as well.
So it looks like a few people have frozen when the numbers got a bit too big.
Oh yes, just don't change number extremely. That's probably gonna blow your computer.
So one of the good things about this is you can start off. You can actually start off with 5 particles, and then simulate it and get it all working, and then increase the number.
Yeah. So once I get it working, actually, just as Marcus said, I can change my burst number to a higher number. I probably have like 30, and let it simulate again. Yeah, that's it. And now I have more fireworks.
I got a question about the spoon by travel. I just missed the setting for that one. I just want to double check I got it right. Did you change anything here?
No, actually, I just select by travel distance.
All right, that's it. Thank you.
Nice. And also you can change the spawn offspring number as well, so which defines how many new particles going to generate. So I keep it as 1. You can keep it as 3 or 4. That's all right.
Yanyi, how do you get that fireworks explosion look? I think I might have missed a step.
I think the explosion look is defined by the speed random 3D. So we set some speed, we set its shooting up by the first speed. So that's along the icon IRA. And then we set some force, make it dropping to the ground. And then for the second group of the particles, we just make it shooting a random 3D. So the particles actually not really following any direction. It's just randomly go anywhere.
Just double checking as well. My fireworks don't start to explode until 50 seconds. Is that right? I don't know. Is that 50? I don't know if that's seconds or whatever it is.
Frames.
I think that's 50 frame is probably not really right. Actually, we set up the time when we set up time test. Probably check this. I set up the event age at 50, not the frame as 50, which means the particles, once the particles burst after 50 frames, it will explode. But the particles actually burst within 30 frames, so not all of the particles gonna explode at the 50. Actually, it's probably explode between 50 to 80, if that makes sense.
That's right. Yeah, that's what I have. Okay, thanks.
Nice.
What setting was the delete event? Was it particle age?
Yes, that's a particle. That's an event age.
Okay, great.
Have we changed any value in slow? I missed that step.
So which spawn?
Slow.
Oh, slow.
Yeah.
So slow, when I said slow is 10%, but you can try probably 5 to 20 to see which one suits your scenarios better. So slow is just really straightforward. It's just like slow down all of the speed and slow down all the simulations.
Okay.
Can you show your simulation again just to see if it matches?
It doesn't need to be exactly matches. So like
it's just
each of the
all of my explosions are happening, they're not moving far from the original explosion point. So the things move out and then they all explode kind of in spot.
So that probably 2 reasons. So probably check your speed random 3D, see the magnitude, is that enough? Or the other one probably because that delayed it too fast. So maybe change the delayed event to a higher event age number.
Okay.
Yeah. So don't worry about those settings. I can share these types of files with you after the class. In the class, I think the purpose is generally we need to, get a little bit familiar with these operators, see what these operators can do.
I've got just 2 questions, sorry. Yeah. One was with the delay, you know how it's like the range is 10 to 20? Can you just explain further what that exactly means?
Okay, so the event age range between 10 to 20 is kind of like have a little bit of variation between 10 to 20s. So if you set 10 to 10, all the particles gonna delete it after this event happens to it 10 frames at 10 frames. But
so you're giving it like variation.
Yeah.
Okay, cool. And then the other question was, if I want to change my particles to teapots exploding, how do I do that again?
Sorry, what?
If I wanted to change the particles to teapots, how do you do that again? Wasn't it within display? I forgot.
Yes, so by changing it to customize the shape, we need to add one more thing called shape.
Oh, that's right.
To give it a shape. And after give it a shape, so that's probably not really suitable for this firework one, but let's have a look. Then changing the shape, and we need to change the display type to the geometry. So then you will see, actually now we're shooting up some cubes, and it will burst into some dots particles.
So did everyone understand the delete particle thing? No, I think it might be good to go through that process of the delete particle bit where they kind of die off after a certain age.
I've got a question.
Yeah.
About that delete one. You know how it's supposed to go up and then explodes and then it explodes for a second time. That's what the delete does. I'm assuming. It stops it.
No, actually, delete just like delete all the particles. Just we burst the particles and delete just like make it disappear. So it's not really bursted into the second. So bursted into second actually is the spawn. Yeah.
If you just turn off the delete, you can see the difference. Like if you don't have the delete, the whole particles will go all the way down and you see the whole colors. But when you have delete on, it will kind of disappear it after a certain time. That way it looks more realistic.
Yeah, that's a very good way. So if you like just click on the delete icon over there, have a look, your particles will always be there into the time end, so it won't disappear. So now if I have like more time frames, have like maybe 500, why my keyboard is not working? Okay, cool. So 500, now I have 500 frames. And when I do the simulation again, the particles gonna keep dropping down. It won't display, it will always be there. But when we have the delay on, it will delay the particles after a certain frame. So now I have my delay on. It will disappear because all the particles has been deleted. So for the delayed, you will find actually most of these particles have a thing called timing. So what is this timing do is define when these operators gonna happen. So normally by default, you will have timing by set to continuous. So continuous means after the the operators before, these operators gonna happen. So these operators gonna happen in sequence. So happen continuously. So for this delayed, we set up to event age, which means, so this is an event, this is an event, and this is an event. So all of these are events. So event age means when the event happens after, when the event happens to that certain particles, and after the frames range we set to it, it will be deleted. So for example, if we have a particles, burst at the second time at here. So that's the second group particles the particle we have. So it burst and it happens in this event. After this burst, after 10 to 20 frames, it will be deleted. So in these scenarios, the event age and the particle age probably doesn't make too much differences, because the one we have in this event is the burst. But if we don't have these bursts at this event, we have other operator under this event. It only happens to that particles after certain events happened, that kind of that certain phrase.
The range always refers to the frame range, the frame numbers.
Yes.
So
that's 10. Yeah. So that doesn't mean it's gonna delete it at the 10, frame 10. It just means when the particles are generated after that, after 10 frames, yeah, it will disappear. Also, this delay can be used by frame as well. So if you set to frame and set maybe, okay, now I want these particles delayed at exactly 100 frames, you would see at 100 frame, all the particles will be deleted. It's simulating. So when it's simulating, you will find out this progress bars over there. So it shows how much simulation it has already done. So this only happens once. If you don't change anything in your particle flow, in your flow, it will save these simulations to your cache. Before I change it, I really should change the particle numbers to a smaller number, because this is probably going to take a while.
Yeah, not related to that, but the frames, how do you increase them to 500? Because I only have 100 here.
Okay, so by changing the frame, there's a clock over here at your animation bar. It's really at the bottom of the
Yeah, I
3ds
see
Max
it.
interface. And click on that.
Enter.
Yeah, you will see the end time frame. You can set, like, we can talk about this once the simulation is done, because I can do nothing. Yeah. So actually, in that interface, you can set how many frames you have for these scenarios, or even like you can set to time, set by time. So like how many minutes, like how many seconds or how many minutes you want to have for the scenario. Am I freeze?
Yes, you are.
I think I probably go too ambitious with that delay thing.
Just a recommendation. I've had this experience before. If you turn your camera off, actually, it helps the computer.
Okay. So I think my whole screen has been freezed. So okay.
Oops.
Oops. Okay, cool.
It's probably a good time to point out that you should save regularly.
Yeah, I did. So
Actually,
I gotta stop the share for now because I need to bring back. Yeah.
It's worth pointing out if you do have the machine crash and you hadn't been diligent about hitting the old Control S every now and then, Max will do an autosave for you, and you need to dig a little bit to find it, but it'll do, I think it does 3 by default, so every 5 minutes maybe it'll save a version, and it just kind of keeps writing over them. I think in the preferences you can set it to have more than 3, which I like to set it to be like 25 or something.
The better side for this type flow, you know, the advantage of the type flow than the old particle system, one of them is the old particle system gonna only use your CPU, and the new type flow is it's really gonna optimize your computer. It's gonna use your GPU, it's gonna use your CPU, it's gonna use like your RAMs as well. So that's pretty nice. So why that's the reason why it's much faster than the old one. Yeah.
Question. I can't get along with the speed. Like it is not slowing down. It is having the same similar speed.
Did you have the slow?
Yeah.
And did you change the velocity numbers to a higher number?
Higher number as in?
Yeah, higher percentage. Probably, I think the default is 5 or 2. Probably change that to 10.
No, I have changed till 20. Then also it has shown anything correct.
Okay. That's a bit. My computer is frozen again. So yeah, bummer.
Sorry, the other thing to keep in mind is this is a bit experimental. So this is all in beta, and I think we're on the what is it? The bleeding, cutting something edge of using emerging technology. So it's expect that it's we're going to have some occasional crashes.
Yeah.
I got it on 25%.
Just like don't acting like me, just remember to change your particles to a smaller number, then do your experiment. So you gotta keep that in your mind all the time.
Okay, the number is great for my particles.
Yeah. Cool.
We might be worth moving on to the next section. So I think we've got a couple of other pretty exciting things that we might just touch on. Maybe we don't necessarily. Well, you can try and follow along. I'll try and follow on, but I'm pretty sure I won't be able to. But there's a couple of great things that'd be good to get through before we move on to the next bit.
Yeah, and we want to cover as much as overreaders as possible. So as long, well, at least we want to cover each group of the, the overreaders. So at the firework, we actually talk about the burst, the speed and force. So those are really common, and we talked about the test. So we not only we have the time test, we also have the probability test, we have the object test. Those are all very useful. I can show you a little bit in other two examples. And we talk about display. So as long as you know burst, icon, speed, and display, you can start play with the type flow. So, okay, my computer's back. Let me open.
Do we delete all that and start from the start?
You don't need to delete it. You can just like close the type flow icon layer. So as you say, I have nothing in my scenarios, which is because the layer has been off. So if I turn on the type flow layer, it will start the simulation. But if I turn that off, it will turn off the type flow simulation. So yeah, go ahead.
I just wanted to ask a question. How do you make layers? Because I can't really see to have layers.
There's two toggles. Like if you, it's over here. So next to your line, actually you have Scene Explorer, you have your Layer Explorer. So you can't find layers. Probably because you're in Scene Explorer. So you just need to click on this layer, saying, I don't really need to have a second one. It will bring up your, Layer Explorer and show you all the layers. Also, you can toggle that from here. So you can sort by categories, hierarchies, or you can sort by layers. So if I sort by layer, you should be able to see your layers. And remember to tick all of this on. So if this is off, which means you won't see all of the shapes. So yeah.
Now what I'm trying to do, I'm trying to put the tri-flows in one like sub layer, let's just like have them separate. Well, yeah. when I click on that shape at the top next to the eye thingy, it doesn't put them in one, if you know what I mean.
Okay, so if you want to put like something, for example, these two onto a layer, so you can either drag it or you can create a new layer. Just click on that create a button and we'll bring it into a new layer.
It worked. Thank you.
Okay, no worries. No worries. And let's start something new. So the next one I want to show you guys actually is pretty similar to the firework one, but at this one we're going to talk about a little bit of physics. So at this one, yeah, type flow balance. Let me open my type flow balance. And we will talk a little bit more about the burst as well. So at this one, I have my favorite teapot, and this teapot will go up and, like break into pieces, and even like a little bit bouncing at the ground. So that's all done by the physics under the type flow. So let's start it. Okay. So what we need to do is same thing, create a type flow icon. That's our new type flow. And this time we're not going to use the icon. So to position the bus, now we're going to try something new with the bus. We're going to bus onto the surface. So what I'm going to create a plane as my surface bus plane. So now if I open my type flow editor, okay, I'm not going to use the bus over there. I'm going to use the bus surface. So there's one thing you probably very useful for you guys is if you click on your operator, you probably see a little bit of text on here. So that's the simple description for this operator. So you can, know better about this operator and like simply know what we can do. And also better way to do like understand an operator is go to the Tyson's website, the download one, and they have like the full documentation for all of the operators, and some tips are really useful. Highly recommended you read those. All right, so burst surface, that's very straightforward. We can burst particles from the surface, like not only plane, we can burst from a teapot, we can burst from any of the surface. So we just need to pick that, and that's probably too small. If I change it to, let's have a shape onto that so you can see. So if you notice there's little sprites actually at the plane. If I turn on the edges, you will see actually these kind of particles are burst at the vertex of the surface, which is because I set the mode, particle burst mode to all vertexes. Also, you can try with all faces, which is like just burst 2 particles per faces, and there's other options as well. You can burst onto selected faces, which means like you can have an added poly on top of your plane, and just select some of them. This is the polygons, and after that, you will see what's my probably need.
You deselected them.
Selected faces. I deselect them. So you will see those particles only burst onto selected faces. So this is burst face. Let's see those. I want them burst onto the vertex for now. So next one I want to do is I want to give it a shape. So I simply add a shape underneath of the burst surface. So we talked about a shape before. You can customize what kind of shape you want. I'm gonna go with my favorite teapot. You can go with any other shapes you want. Just
oh dear.
of your teapot, actually you need to down in type flow. So go to your shape. There's a distribution, and there's a scale. Tick that, and you can change the percentage of that scale. Yep.
Mine works when it's kind of linked, I think, on my side. I changed the scale of the teapot and it worked.
Yeah, mine didn't. That's why I was wondering. Because I was like, oh, they're way too big. I've changed the scale of it and it's still showing the teapot changed, but the reference ones didn't. I mean, the following ones didn't.
Yeah, well, sometimes probably type flow needs some time to simulate, or you probably just need to pick again, I think. Yeah.
Danny, for the recording, would you mind doing a quick recap of the steps so far?
So yes, of course. So for this bouncing one, what we do is like we just do a burst from surface. We have a surface. I just simply create a plane in the scenarios and pick the plane for my burst surface. And I choose the particle burst types to all vertexes. There's other options here as well. So you can use other options. And I add a shape. So at the shape, we can choose different meshes. Under the mesh, you can use 2D or default 3D within the type flow. What we use is we use a reference node. This should, like, if you not pick anyone, this should be now. Just click on that now. Click on this mesh you want to use. That will pick the mesh. And after that, I change the display to geometry. So it will display all the particles using the geometries I picked for the shape. And after that, I add a speed under the shape, which I just want to do the similar thing as the firework. I want to have my teapot going up. So yeah, that's all I do. And now, after going up, if you still remember, for the firework, what we did is we add a force. But this one, we want to treat this teapot as real geometries. We want to add some real physics onto that. So it can be break, or it can be bounced, or it have a gravity onto that. So how we do that is if you notice, there are some gray, like purple more operators over there start with physics X. So those are the operators you can use to apply some real physics or simulate some real physics onto the objects. So what I'm gonna do is I'm gonna do a physics shape, add underneath of the speed, and here it should, and you will notice my my teapot immediately stopped working, which is just because we don't have enough speed for it coming up. It's too heavy. So we just need to go back to the speed. I change it to 20. That looks fine. And after that, after the simulation, you can see the teapot is going up and dropping down onto the plane. And it's like doing like, and rotate like a real physics thing. So let's talk more about the physics shapes. How the physics shapes recognize the shape of the object. So if you display the whole, you will see this is actually the shape physics recognize. It will treat this shape as an object. So you have other options as well. If you choose sphere, I can show you what's the difference between sphere and box. It will treat this object as a box or a sphere. And if you want to use some like customized geometries, you probably want to keep that as convex. Cool. And now, another really important thing is dynamics. So under dynamics, there's a bounce and friction. So this one defines how much bounce this can do, how much these objects, more like a ball, like rubber ball, not a a glass or something. If you change this to a higher number, for example, now we have 0.50 now. Let's change it to 1 and have a look. And after the simulation, you will see all my object actually bouncing much than before. So if these can be simulate some like different materials. If you have like a rubber one, you probably change the bouncing number. The restitution number higher. If you have a really, class 1, it's really not bouncing in the real world, you change this to a relatively slow. T-bot not moving is probably just because, as I said, the speed is not enough. Go to your speed, change your magnitude to 20. So it will give you more speed, like make your teapot bouncing up. All right. So at the fractions, which defines how easy your object being, how the level of the object fraction. So it's really straightforward. If you change this to a higher number, it's easier to break into the pieces. And what this physics can be doing is not just only simulate the bouncing onto the ground, and also it can these kind of hole can simulate to each other as well. For example, once these two particles crash on each other, they will bounce away from each other as well. So these are real physics. So now let's have a look at the hole. So I want to talk more about the hole to show you the differences between the hole. So if I change my shape, let me change my shape to a low sphere. So I'll change to a sphere, change my distribution, make this bigger so everyone can see. And yeah, I'll record. Yeah, yeah, I'm recording. Cool. And then I probably don't need these many. Yeah, I changed my balls to a sphere. If I now keep my physics as sphere, like my whole type as sphere, once the simulation is down, you will see that probably my bouncing type. Okay, keep it as 1 point. That's a bit weird. So let me show you the example I created before. So I think that somehow I broke that bounce. So I changed my shape to a sphere, geosphere. Let's make it bigger. All right. And I changed my physics to sphere as well. So what happens actually, these spheres gonna mimic the ball, and once it's dropping down, it's gonna rolling away. So, but if I apply the whole type to a box, that won't make sense because it barely rolling, because that treating that one as a box. So it will roll like a box. So when you do the shape and the physics shape, try to make sure you set the hole and the shape to the same types. So normally if you change it to convex hole, that is the safest. Anyone have question about the hole and the shape?
I guess what I've noticed is that mine are you're also going on a weird projection and kind of falling randomly, and mine are kind of just going straight up and down. Is there a step I've missed on that?
That is just because of the different number of the dynamics. So if you're setting the dynamics bouncing reflection 2.5 as me, you should have like the similar result I have.
Sorry.
Differently, but it doesn't spread.
Yeah, I think it's because of the Voronoi, whatever that is, because I added that based on your previous script and it actually worked, and the mesh.
I have disabled Voronoi, so it shouldn't, like what Voronoi did is actually it's gonna break that into different like several pieces. So I don't think that's the one. Probably because we are shooting up the speed value, float value. I changed the diversity to 20, so it can have a little bit, variety of the speed. So it's not directly shooting up. It's kind of like shooting some, directions.
Yeah, that's what I missed.
Cool. And now we can talk about the Voronoi fracture. So what Voronoi fracture is like, it can break this object with like into pieces with the Voronoi fracture, using its algorithm to break it into the pieces. So simply just like drag a Voronoi, where is it? Voronoi, here, Voronoi fractures underneath of the physics shapes. You don't need to change anything about it. If you want, you can change, the variation about underneath of that. So give it more variations. And after that, when it's after the simulation, when your teapot dropping down onto the ground or they, touch on each other, they will break into pieces.
Sorry, another thing. On the speed, I changed divergence, I think, and that made the balls separate and go away.
Yeah. So, but like still on the ground.
Yeah, they only like they rolled aside. They rolled away from the scene when I increased that.
Maybe increase your magnitude more a little bit. I set as 20. You probably can set at 30. Some of you probably have like really like larger shape than mine. So physics X gonna treat that as a heavier object, and you need more speed to like push it up to the sky.
One thing I noticed is that like my teapots are going up and down at a different rate. They're not all uniform. Is that how it's meant to be because of physics X?
Yes, I think that's more like down because of the magnitude has set a little bit like variation.
Okay. Yeah.
So that default, I think, set to 15. If you change that to 0, they probably will have the same speed.
Okay, thanks.
No worries. Everyone happy with that? So not only the variety fractures are available in break things into pieces, we can notice like there are more fractures you probably can explore during the week. There's phase explore fractures. The break fracture is really useful when you simulate something hitting onto a brick wall. It will break on like a brick. So these are pretty similar as the Voronoi fractures. Voronoi fractures is just like more randomly, it can randomly break the things into the pieces.
It's quite good also if you want to simulate the Beijing swimming pool real fast, like.
Oh yeah. Voronoi is really popular like 10 years ago, around 20. 10, yeah.
Big in the early 2000s.
Hmm. All right. Yeah.
No.
I saw somebody has questions. So this is one. It's just example one to introduce you to physics, shapes, and Voronoi fractures. What?
Pat's comment. Yes, it's very representative of all of our plans for 2020.
Exactly. Yeah.
Shattered into Voronoi chunks. Yeah.
Yeah.
Can we move on, Tianyi? This is starting to get depressing now that I've heard that comment.
Yes. So that is all about the bouncing, and we talked about a shape before. So if you want to export into the real viewport, if already mentioned that, I'll probably show you how to do it. Like by export these kind of shapes, you just need to add export particles, and you can export object that's export to the scenarios. If you export a type cache, that's basically gonna export your type cache. If basically gonna export this type cache into a file, you can save that file, and then you don't need to do the simulation again when you open the file. When you open your 3ds Max, probably the other day. So some simulation gonna take really long time, so you don't want to lose it once it's finished. You probably want to save it to some file. And if we want to like rendering or export as objects, you do need to have a mesh with mesh in the scenario in the events. So by adding like export as object, you need to set as triangle meshes. If you just don't want to render that, you can set just as render instance. And one thing to be noticed is sometimes you have like several flow. Yeah, my flow simulation like me. So that's my breaking flow, and I have another flow. The particle just like shrinking. Expanding out. So if you want to export all of them, you just need to have your export particles not attaching to any of the event. Just put it in the empty viewport, and that when you export the type cache or to like other type cache or object, will export all of them instead of one of the object. If you link to one of them, it will only export one event. If you put the empty place, it will export all of them. All right, so that's the bouncing I want to talk about. The other thing, yeah, next one is very exciting. Voxels. So let me find my voxels. Here we go. So some of you probably already explored some plugin or script from Scriptbot can turn object into voxels. That can be really quick down within the type flow. So if you already noticed, yes, we actually have a burst voxels in the type flow. So which means you can build anything, any shapes with the voxels. So for example, what I have here actually is a Boolean teapot. So we mentioned about a type Boolean before. So this is just a really random shape I created, like a box, a sphere, and a teapot. I just like type Boolean, union them together. And after that, I add my burst voxels. Under the burst voxels, I just simply pick that teapot, pick that type Boolean. And then boom, that's my voxels. And at like how big is the the voxels I want to set is defining here. So you can set, if you set to 1, which means like the voxel is going to be set to 1 by 1 by 1 boxes, and this 1 by 1 box is going to consist of your big boolean. So mine is set to 2. So that means these small rectangles, if I turn on my, yeah, that would be much clearer. These little boxes 2 by 2 by 2. So that's very quick, very simple. And of course, if you only have the voxels, you won't see the result because you don't have a shape with that. So you only see the particles. So you need to apply some shape. You're really slow. Okay, so add the shape. If you just want to do normal voxels, you can just set this to the cube. All right, set this to the cube and display as a geometry. So this is a really simple one, can turn an object onto a voxels. So since we have a shape, so which means we can use any shape we want to, make the voxel. So, but one thing you probably need to remember is try to use this voxel size as the base of that object. Say, for example, this one. So I have a base ball, and I want to, this is a reference ball I have, and I want to replace that with some other shapes. So I just simply pick the voxel base, same at the burst voxels, but at the shape, I can pick a reference node, or at the shape, let's check out what is the size here. So that's 20 by 20 by 20. So which means I need to create something 20 by within the 20 by 20. So what I'm gonna do is I create a box 20 by 20 by 20 and edit poly. We showed, I think it's last week. I'm gonna create a little, connect. I'm gonna move these to edge down. So this is kind of like pitched roof house I have. I'm gonna use that to replace the box I have. So you can do, the quicker way actually to do the simulation is right click on that, save that as a V-Ray mesh. So, but if you don't have a V-Ray, I think that's fine. You can still under the shape using the reference node, I think, and pick that, and that shows the geometries. So, type voxels. So once you get that, let me hide my base. So actually, what I'm doing is I'm using this box to replace this little, pitched house to replace the voxel boxes. And now if I add some orientation, I want to random that as horizontal. And also I can scale that. Their scale over here. So probably do, I want to scale the Y, no, want to set others as 100, maybe the X at 30, that's too much, 200, and add a little bit of variety onto that. So maybe 50. So this is more like a virtual campus Herzog Demaran's house. Yeah. Virtual, have you been to a virtual campus? This is just a quick way to model that, I think. Yeah, you've probably seen this one before. So this is just a quick way, you know, to model this kind of the architecture. All right, so also you can turn everything, basically you can turn everything very quickly into a Minecraft city. So this is something what I did, very, you know, quick Gribble city, just plain edit poly and add some Gribble onto that and use that as a base of my voxels. Turn off the wrong thing and turn that into a, you know, Minecraft Gribble city. So this probably can be quite useful for architecture or a quick city modeling. All right, and what time is it? I still have some time. So I do need some time to play with this. So I think this one is really straightforward. Actually, it's just one operator we want to use. But we do need to combine the voxels operator with the shape, so to make it like look like a real voxels instead of a bunch of particles. Cool. So let's take this one more step. Let's do some cool stuff. So if I think this this is I want to talk about like the raster deformation or the display. I think if you use the other software, I think F.Grinder has displays as well. Grasshopper has displays as well. So basically, it's like using a raster map to display onto a plane. So what I have here, so what you need to have is like you have a plane. All right, we create a plane. I probably set that 200 by 200. And on top of that, I can have a modifier called displays. And at the displays, I can use any map to make the displays. What I use is like a random heat map I download online, shows the underground heat of Australia. But this is more common use if you have a DEM, which is DEM. If you probably heard about that if you attend last semester's informatics class. So DEM is digital elevation modeling. So this kind of map is called hive map. So actually, by using display, you can use a hive map to easily form a terrain or form a landscape. So for example, I want to have a clean one. Yep, this one looks good. Yeah, if I'm using that, I will change my material. So we'll talk more about the material in next week, so don't be too worried about that. Just want to show you about this display. Just create a very material very standard material. Just apply onto that. So if we're using display, let's have some strength onto that, have 100. And if you set this to 0, nothing will happen. It's just like you need to set some strength onto that. And what it do is we'll use that heat map I just downloaded to form this. So this is called, this is kind of like raster deformation, and this is display. So this is not really relevant to type flow yet. This is what we do in Max. So what we can use combined with type flow is we can do a really quick voxelized 3D data visualization combined with that. So for example, what I have here, just as I said, this is really, really low resolution. I randomly download that from internet. This is showing the underground heat map. Underground heat of Australia is a heat map for that. I want to visualize this in 3D. What I can do is I can use that map and do a display. And if we want to see the color of the real color, we need to apply the material of that. So we'll talk about the material further in next week, but if you want to do quick materials, drag various materials, and under the diffuse, you can do a material, and you can choose a beam map. Use the same beam map. And now if I drag that onto the thing, so now you can, this is a quick 3D data visualizing of that, like, raster data. If we have this plane segment more, we'll have more accurate result. So if you're happy with that, that's fine. But like if you want to do a voxelized, voxel styled visualization, we can use with type flow. So bring your type flow window again. Using that burst voxels to pick that map you have, you just generate it and add the shape. So this shape just like define what kind of the shape the voxel is gonna do. And it's a little bit laggy.
Can't imagine why. Not doing anything particularly complicated.
Probably too many voxels, because like I set the voxel size relatively really small to show the result. See the geometry. So if I hide all the original geometry, you will see that's a voxelized data visualize 3D data visualization, and you can take the display material and apply that material we have onto the type flow logo. It will directly apply onto this geometry. So here you can see actually this type flow logo can be add on lots of modifiers as well. It can be treated as an object. It can apply materials onto that. It can even add some, you can probably add band onto this type flow icon, which is gonna, set the whole like modifiers on top of these, the simulation result of your type flow. So now you probably notice this is not mapping right. It treats each of the box as a individual and trying to mapping the map we have onto the small boxes. So we don't really want that. So here we need to introduce one thing called mapping. So mapping is on the yeah, mapping is really laggy, I don't know why. So mapping is just before the beige shape area. There's some blue one are really, all the blue one relate to the materials and renderings. So mapping is one of them. So if you apply the mappings over here, and you can affect the particles mapping override, and you can mapping from the objects. So what we want to get the mapping from the original shape. So I just pick the object we have, that one, pick under the mapping, and that mapping has been correct. So this is like voxelized 3D 3D data visualize. We can quickly get by a 3ds Max displays and burst voxels by type flow. Yeah, are good. And the other very cool thing is all of these colors actually can apply to voxels. So there's one thing called voxel colors. It can be grabbed from the map as well. So if I change the geometries into some large stuff, for example, each of the boxes you can see already obtained from that map. So yeah, that looks cool. This is just some like really cool data visualization thing I want to show you. And we can have a little bit chance to talk about mapping and material. We will talk about more about materials next week and the rendering. Any?
So
yeah, you got.
Tianyi, to if you wanted to render that, you'd have to put a sort of mesh.
Yes, that's correct.
Mesh onto that. So try mesh or something.
Yes, if you want to render that or export that, you need to have a mesh underneath of that and set that at the triangle mesh or render instance. Okay, so that's something about voxels. Do you want to? That's pretty straightforward. Do you need some time to have a go? What time is 5:40? We have turning. Yeah. 3, 4, 5. Is our class, and at 6, Marcus?
I think theoretically, yes.
Yeah. So
we might have to leave it there because we need to have a look at the weekly exercises.
yeah, I'll probably show you just the result, like the thing I haven't showed today. And I can send these TypeFlow files to you. You probably can explore during the week. I do think that's a good idea. So the thing I haven't shown you is one is make an inflatable architecture. So any shape in 3ds Max can be inflatables. They can be shrinked or put some airs in, and you can even set more collisions or restrictions onto that. So this is really fun simulation as well, and that is not hard to do. I can share the file with you, and since you already know the basic knowledge about TypeFlow, you probably can quickly figure it out how I did it. And the other thing we haven't showed is the agent-based wayfinding. So it's not really a really how to say this, accurate agent-based finding. It's just really basic agent-based finding. So you can have some particles simulate as agent, like for example, this is probably a pedestrian coming out from a metro station. You can set collisions, is trying to find a way in the city grid, and you can set target, and you can even trace the track. You can even trace the track each particle go, and by using this same logic, we can do a simple wind simulation. All right. So I'll probably leave this to you guys to explore during the week.
I just wanted to see what particle or what component do you use to slow things down? Because I did a render during the week, and that 100 frames only is like 3 seconds, and then I had to use an outside program to slow the video down.
You mean in TypeFlow?
Yeah, to slow the whole thing down. So like in instead of having the whole thing running 100 frames, running it in 500 frames instead.
Yeah. So there's a couple of ways. One, you can use slow. So that's an operator you can use. So you can probably slow down. If you want to slow down one step, that's probably the best way you want to go. So use the slow. The other way is actually under the TypeFlow settings. There's one called retimer. So under here, you can enable the simulation retimer, and you can set up like what is the speed you want to have this simulation.
The other thing is, Jaffa, is like you have control over the total number of frames. So normally they're set to, was it 25 frames per second? Something like that, which is sort of, TV, film. So that, there's 25 frames in each second. So if you want something to go for 10 seconds, you would divide by how many frames you want, and then so you can multiply them out. There's a bunch of different render settings that you can tinker with, that can either, you don't have to render every frame, and you can render or you can render every frame. So those are some of the things you can tinker with to adjust the overall length.
Okay, maybe one day we can go over the rendering settings with V-Ray or something.
Yeah, next week. I think we plan to do that next week. Yeah, and I like for the frame rates, Mark is right. Like 25 for most of the animation. Well, like movies, they tend to use 29.97 and 30s. You can change those here. So the clock we mentioned when my computer is frozen. So it's just over here. So here you can choose the time frame rate. So you can choose what is the film use, what is the NTSC use, and you can customize that as well. You can change that to 25. If you change that to 25, which means you have 25 frames per second. And here you can change what is the start of the animation and the length of the animation. This is per frame. So if you probably need to do a little calculation if you're using frames as your like your scale, but like you can also set that to time. So if you set that to SMPD, you can change that. This is actually defined by minutes and seconds. You can set like exactly how how long is our animation.
Makes sense.
Yep.
I wanted to get this dialog box when I was doing my work for animation, but I couldn't get this dialog box. I tried my best to get it, this one.
So it is here. It's called time configuring. So this is the animation bar, and
Yes.
at here there's a little clock with a, what is that? Anyway, if you hover onto that, it's called time configuration, and click on that, it will pop up.
I think in older versions of Max, I don't know if it had that box. You just had to right click on that area. So if you right clicked over the plus.
Okay. Because in my one, I couldn't find it, that one.
Yeah.
So that could be it. So just right click in that general vicinity.
It says time configuration, that one?
Yeah, time configuration.
All right. Okay, right. Okay, I understand.
Yeah. Before we, leave the Thai floor and start to do the presentation, there's one more thing I want to mention is under the main setting, some simulation you probably find out is not really accurate, which is just because you don't have enough timestamps. So under the main settings, if you change your timestamps to like 124 or 128, it will give you much more accurate simulation. This just means like it will do the simulation, as the smaller number you get, the more accurate simulation you can get. And the other one to, increase the simulation accuracy, but slow down the simulation, speed is the particle bind finder, bind solver. We didn't really talk about the particle bind today, but you will use it for the inflatable architecture. So if you have a look at that script during the Thai flow during this week, you will find the bind. So that bind probably you need to change the solver setting steps to a higher number to get a better, quality, better and more accurate result of the particle bind. So that's it. That's all I want to mention for the main settings. Other things, you just click what it is.
All right. So thank you. I think, I don't know, that's a fantastic demonstration of an incredibly complex set of tools. So thank you, Tianyi. I managed to follow along this time, which is new. No mean feat. Yeah, so thank you. That I think hopefully it's, I mean, it might not be apparent immediately, but there's so much gold in what you've just shown for anyone that's going to be modeling architecture and urban design stuff. So thank you. And so what we'll do, I think, because we'll try and keep roughly to time. I think the nature of the size of the group and the complexity of teaching completely through Zoom, we might not manage to keep things on time every time, but what we'll maybe do, there was a suggestion in the comments to break up into 3 groups. I think that's quite a good idea. And in fact, I mean, this is the sort of stuff that hopefully you guys get into the habit of doing, which is a sort of peer review type system. So what we'll do is we might take a 5-minute break, and what we'll do is we'll put you all into 3 different groups, and in your groups, we'll just get you to present to each other the research that you've done over the week, and I think we'll just sort of pop in and out of the different groups if I can work out how to do that. But before we go into the next stage, I might just, because I think probably the different groups will go for different lengths. That seemed to happen last time, but the next week's exercise is, well, very nicely related to what we've done today. I think Tianyi's sort of given us a bit of a taster of some of the very exciting world of Thai flow and particle simulations and voxels and all of the kind of interesting kind of things that you might start to explore. This week, instead of having a kind of different, unrelated thing to explore, what we want you to do is just take some of the things that we've touched on in class, do a little bit of research. There are quite a few, pretty interesting video tutorials if you dig on YouTube. There's actually a Facebook group which might be worth having a look at, which is where people share Tyflow ideas, and some of it's a bit intimidating because it looks absolutely amazing, but they seem pretty eager to help people get into the Tyflow. So we want you to explore the Tyflow, and I guess, with the same sort of idea as last week, it's sort of thinking about how some of these techniques or tools or kind of technologies might apply to specific areas of architecture and urban design, and it might be kind of ways of analyzing or representing data like Tianyi was showing, or it might be, it could be facade generation, or pedestrian simulation to work out egress or something along those lines. So hopefully this is it should be reasonably fun, I think. You could be looking at inflatable buildings, stuffing. You can do stuff like stuff one building into another building. So many cool things you can do with Tyflow. So any questions on any of that?
I think you mentioned, Marcus, that we were going into our own groups this week. How do we figure that out?
Yes, that is a very good question. Thank you. So what we'll do, so we'll break off into the discussion groups, and then what we'll let you do is pick your own group members, and maybe what we can do is set up a in that same Miro, we'll just set up some blank group numbers and pages, so that kind of where we have currently there's sort of group 1, 2, 3, and there's a rectangle to plop your face into. We'll just set up some empty ones and let you sort out just join groups that you like the look of, or you can set up your own group of buddies or whatever. And I guess you've all communicated with each other, you've worked with each other, you can kind of, I guess, do a bit of negotiation. And maybe just let us know if there's any problems with that. And we might have to do a little bit of social engineering, but ideally you can just sort of group yourselves. Does that make sense?
Sounds good.
Good.